All right, so this one says if the graph of f has a tangent line for all the x's. And so on our graph, for every single x value, we have a tangent line. With these numbers, or these points, so at 1.99, we have a y value at 4.98. 8. And so we have a point right there. And then at 5.04, 004, we have, no, I'm sorry. So I got the wrong one. 2.01, we have a number at 5.04, 004. Okay, so 5.004. Okay, so here's the first thing we need to know. Because f has a tangent line for every x, that means this function is continuous. Because if it didn't have a function for every, or if it didn't have a tangent line for every x, then that means this function might not be continuous. So because we know it's continuous, the line that connects these two, the function that connects these two, would have no holes. So I don't know what it looks like. I'm just connecting them to give an example of what it looks like. Then which of the following is the best approximation to the tangent line for at x equals 2? Now x equals 2 is right here. If we have a secant line right here that has a slope of, let's see, 5.004 minus 4.988, and then we have 2.01 minus 1.99, what's the best approximation for the slope of a tangent line at 2? Okay, now this is the average rate of change that we're finding right here. We want to find the instantaneous rate of change for the tangent line. Now, I don't know where this tangent line is because I don't know what my function looks like, but it could look like this. All I know is that 1.99 and 2.01 make 2 exactly in between those. So because we're getting two x values that are really close to 2, there's a good chance that our tangent line is going to equal whatever we have for this one, or just be really close to. So we have to find this really quick. So we got to subtract those and subtract that. This has a c, so you would be using a calculator for this, and we get a decimal. So let's figure that out really quick. So it looks like we get 0.8. So that's the secant line. So would you think, so because we know that this average rate of change would be close to the instantaneous rate of change, we're going to eliminate these last 3 choices. It can't be that one, or this one. All right, so what about our y-intercept? Which y-intercept would this most likely be? Would it be a 3.4 or would it be a 5? And we're looking for the tangent line. So I don't know if the tangent line is up there or if it's down here.
It'll be at 5.
Yeah. You think it'll be at 5?
Because it's in the middle.
Okay, but here's the thing. At 5, we have a slope that is increasing, which means if at 1.99 we're at 4.988, and this slope is increasing of the secant line, where are we going to be by the time we hit the y-axis? Are we going to be above 5? In between 5.04 and 4.988, or below 4.988? Now, I drew my tangent line above it, but we could have a tangent line, like what if it went like this, and our tangent line is right here? It can be below it. So what would be our best guess? Would it be at 5? Or would you think it's definitely going to be below 5, and so we're probably going to be at a better guess at 3.4? The answer is A. Most likely you're not going to be above 5 or at 5. It's probably going to be 3.4 if our slope is going up at those at that secant line. Okay, I'm sorry it's really small. I had to shrink it up so it would fit. It says the graph of function f is shown above. Which of the following is true? So we have 3 statements that we got to see if it's true. This says the limit as x approaches 2. Is that a plus sign or minus sign?
Minus sign.
It's a minus sign. So from the left equals 1. So as I'm going from the left, are we approaching 1?
Yep.
Yes. Now remember, the limits are always y values. So that one's true. So let's put a little marking next to that one that we know is true. Okay, the next one says as we're approaching 2 from the right, we're approaching -2.
Yep.
And that is true. We're approaching -2 from the right. Okay, and the last one says the limit as x approaches 2. So there's no right or left sign on it, so that's coming from both the left and the right hand sides. So the left side's going to 1, the right side's going to -2. So is this true? Is it approaching -1 since it's right in between? No. Okay, this is not true. The only way this exists is if these two are equal. So we would say that 1 and 2 are the true ones. True statement. All right, look at this next one, number 15 or 14. The graph of f is given above, has a tangent line at every x from -2 to 3. So from -2 to 3. That's not a point. Those are x values. We have a tangent. Wait. The graph has a tangent line at every x except x equals. Okay, we can never have a tangent line at points. Okay, so that's just a fact you got to memorize. If you have a point somewhere in the graph, you can't have a tangent line there. So at +1, the answer is just C. Normally I don't talk about that, about not having a tangent line at a point until we get to chapter 3 when we start talking about derivatives. So if you're getting ready for one of my tests, that is not going to be a question that's on the test.